Good morning. Today is musical day, so I decided that I would go over the notes video for you guys so you can hear them and watch them go. So at the beginning of this, you can see that there are two old example problems from yesterday, except that they're a defined integral. I will do those at the end. There are just three new problems for today. So that's what I want to focus in on are those new problems, and then I'll go back and we can do those. So what's new about today is we are not doing or introducing e to the u, but we have a to the u. And again, you can grab your yellow sheets and help you out with this. Here is the new formula, and it's basically what we did yesterday. So I look at this problem, it has a base of 5, so that makes it an a to the u. I have a negative x in there. So first thing that I'm going to do is I'm going to let my u value be negative x, which makes my du value negative dx. And then I go looking for all of my pieces in my problem. And I see I have my dx, but I'm missing my negative sign. So I'm going to put a negative, oops, can I erase that part? I'm going to put a negative sign inside of it and a negative sign on the outside to balance it. So now I technically have negative integral of 5 u du. Okay, so now looking at my pattern, my answer is going to be negative 5 u, that's a to the u, divided by the natural log of 5, and then my plus c behind it. So something new that you may want to put in here just to help you when you look at your pattern, you may want to put your a value equals 5. So you can also just easily look at this little reference and plug and chug. I'm not done with this problem yet because if we start with x's, we end with x's. So the integral is negative 5 raised to the negative x over natural log of 5 plus c. And this natural log, it does need to be positive. So let's emphasize the absolute value here and the absolute value there. Okay, that is basically the pattern. So let's take a look at the next one. I have all of this stuff, a 7 raised to a power. So I know my a value is going to be 7. But then my u value would be the 3 minus x quantity squared. Now, you have two ways of finding this derivative. You can use your chain rule. 3 minus x to the first power, and then derivative of the inside would be negative 1 dx. Or you could have FOILed it out, but look at the form that the rest of the stuff is in. It's in this 3 minus x, so I want to leave this in the 3 minus x. That means it's du is negative 2, 3 minus x dx. Okay, so what do I have? I look for my pieces. I've got my dx, got it. I've got my 3 minus x, got it. What I'm missing is my negative 2. So I put my negative 2 on the inside, which means I have my negative 1/2 on the outside. So when I rewrite this, I now have negative 1/2 my integral of 7 to the u du, which means that turns into negative 1/2 of, and now I'm following my pattern again, and again, it's nice when I know that the 7 is my base, 7u over the natural log of a plus c. And now filling in my final part, negative 1/2, 7 raised to the, in parentheses, 3 minus x quantity squared power, all over the natural log of 7. Excuse me, don't forget your plus c. Okay, so last problem. Last problems on the back of this. And it's the exact same type of problem, but it's a defined integral. So we've got to practice those two, and I'm thinking of your test early next week. So I see that this is two separate pieces. I can do the integral from 1 to e of 6, let me erase, it's not 6x, 6 raised to the x power dx. So there's one part. Going to subtract the integral from 1 to e of 2 to the x dx. Okay, so that's doing exactly what we just finished. My a value is 6. My u value is x, which means my du value is just dx. So this is technically ready to go. I could solve it, but I'm going to rewrite it as 1 to the e, 6 to the u du. Subtract, and I'm looking at the same thing over here. My a value is 2. My u value is x, and my du value is dx. And then rewriting that is the integral from 1 to e of 2 to the u du. Following my pattern, I'm going to get 6, and I'm going right to the end of this at raised to the x over natural log of 6. Subtract 2 to the x over the natural log of 2. And I am integrating that from 1 to e. Okay, so all that means is I'm plugging that in. So to remind you, top, subtract bottom, and putting it into the top, I'd have 6 to the e over natural log of 6, subtract 2 to the e over the natural log of 2. Okay, so that's my entire top. Subtract. My bottom would be 6 to the first over natural log of 6. Subtract 2 to the first over the natural log of 2. And if I'd actually ask you to find the computation, I'm going to say use calculator. But you need to be able to write that out, especially if this is a test that has that by hand element. I may ask you to write out the pattern, so you need to do that. I'm done with the notes for today. What I'm going to do, though, is I'm going to go back to that front sheet, and those are two review problems from Tuesday. So if you needed to try to remind yourself on what you're doing here, this is what I would do. So turn the video off, do these, you can check your answers. Notice they're defined integrals, so it's just my top, subtract bottom like we've already talked about. Okay, so here we go. If I take a look at that, this has a base e in it. So for base e, we always set the exponent negative, and I'm rewriting it as 1/2 x squared. for my u value. So my du value is going to be negative 1/2 times 2x dx, which is how I got negative x dx for that. I'm looking at my pieces, and notice I have the dx, I have the x, I'm missing the negative sign. So I'm going to put the negative sign in there and the negative sign in there. And when I do that, I end up with negative integral of e to the u du. So if you need to review from yesterday, it is just that I am going to have my negative e to the u, and instead of plus c, it is now between 0 and square root of 2. That's a bad looking 0. So going to do my top subtract bottom, and we're just going to write this out. I don't think I'm going to grab a calculator value on this. For my top, it's going to be negative e raised to my square root of 2. Oops, I goofed. Before I do that, and I'm going to erase for a second, instead, before I plug in, what did I forget to do? I never substituted it back in. So I get negative e raised to my 1/2, negative 1/2 x squared power between square root of 2 over 2. It's early morning here at the Kendall house, so sorry about that. Okay, so now for my top subtract bottom. Okay, so now plugging it in, for my top, I'm going to get negative e raised to the negative 1/2 square root of 2 squared power. Ew, that looks ugly, but oh well. Subtract negative e raised to the negative 1/2 of 0 squared power. Remember, anything to the 0 power becomes 1, so that easily would wipe out. And square root of 2 squared is 2 with the 1/2. This just turns out to be negative e to the negative 1. You could do that without a calculator, but just reminding you of what to do. Okay, so now taking a look at the second one. When I look at this, it's a fraction. So in my head, I'm saying, is this a split? And because of that question, because of that minus sign, my answer is no. Can I bring my bottom to my top without a negative 1 power appearing? And my answer is no. So the next thing on my list is du over u. So now I've got to try that. So my u value becomes the entire bottom, because that's where the u would go, which means my du, the 5 becomes a 0, the negative e to the x, and then times the derivative of x, which would be 1, dx. Hey, all of my pieces are in here. Can you see? Here's my dx, here's my e to the x. So now I could rewrite this integral as the integral from 0 to 1 of du over u, which tells me my answer is going to be negative natural log of u. Wish I could put plus c, but it's going to integrate between 0 and 1. So this becomes the negative natural log of 5 minus e to the x power, integrated from 0 to 1. So just writing out my top subtract bottom, just to make sure that we remember it. For my top, negative natural log of 5 minus e raised to the 1 power. That would be the top. Subtract the bottom of a negative natural log of 5 minus e raised to the 0 power. And again, I would say grab your calculator. This is as far as I expect you to take it without the use of a calculator. Okay, ladies and gents, hope that you had a good day at the musical. I will see you on Thursday and we can review some of this. Bye.